According to the National Electrical Code, receptacles cannot be used as splice points. A multi-wire branch circuit is a circuit that consists of two or more ungrounded conductors that have a voltage between them and a grounded conductor that is common to all ungrounded conductors of the circuit. These circuits originate from the same panel. In a multi-wire branch circuit, all the neutral conductors must be kept intact and unbroken. This means that a neutral conductor cannot be spliced or terminated inside a receptacle. The National Electrical Code's prohibition against using receptacles as splice points applies to both multi-wire branch circuits such as a 2-wire feed and multi-circuit branch circuits such as a 3-wire feed. Receptacles are not designed or intended to be used as junction boxes or splice points. Using them as such can create electrical hazards, including firstly overheating due to poor connections, secondly arcing and sparking, and thirdly reduce safety and reliability of the electrical system. Acceptable methods for splicing wires include firstly junction boxes, secondly wire nuts, thirdly terminal strips, and fourthly crimp connectors. A multi-wire branch circuit supplies multiple loads, such as lighting fixtures or appliances, from a single circuit breaker. This can save on wiring costs and reduce the number of circuit breakers needed in an electrical panel. The primary benefit of a multi-wire branch circuit is the reduction in the total number of conductors required compared to running individual circuits for each load. For example, consider two 120 volts loads. Using standard circuits, you would need 2 hot wires, 2 neutral wires, and a ground wire, totaling 5 conductors. With a multi-wire branch circuit, you can supply both loads using 2 hot wires, 1 neutral wire, and a ground wire, totaling 4 conductors. This saves on materials and reduces conduit fill. To ensure safety and proper operation of multi-wire branch circuits, the National Electrical Code places specific requirements on their installation. One of the most critical requirements is maintaining the integrity of the neutral conductor. The neutral conductor must not be broken or interrupted at any point along the circuit. This is because if the neutral conductor is broken, the voltage balance between the loads can be disrupted. This can lead to one load receiving a higher voltage than intended and the other load receiving a lower voltage. In extreme cases, this voltage imbalance can damage equipment or create a fire hazard. The National Electrical Code addresses multi-wire branch circuits in Article 210.4. This section outlines the requirements for identifying multi-wire branch circuits, the permissible uses of multi-wire branch circuits, and the requirements for the simultaneous disconnection of all ungrounded conductors. Section 210.4d specifically addresses the continuity of the grounded conductor, which states that the continuity of the grounded conductor shall not depend on a device such as a receptacle or switch. This requirement reinforces the prohibition against using receptacles as splice points for the neutral conductor. The overcurrent protection for multi-wire branch circuits must comply with Section 240.20, which requires that each ungrounded conductor be protected by an overcurrent device. The overcurrent device must be rated or set at a value not exceeding the ampacity of the conductor it protects. For example, a 15 amp circuit requires a 15 amp circuit breaker, and a 20 amp circuit requires a 20 amp circuit breaker. All conductors of a multi-wire branch circuit must originate from the same panel board. This requirement ensures that all conductors are subject to the same voltage and that the overcurrent protection devices are properly coordinated. The proper identification of multi-wire branch circuits is essential for safety and maintenance. The National Electrical Code requires that the circuit be clearly identified at the panel board. This can be achieved by labeling the circuit breaker or by using a circuit directory. Additionally, it is good practice to identify the multi-wire branch circuit at each receptacle or switch box. This can be done by using colored tape or labels. When working with multi-wire branch circuits, it is crucial to follow safe work practices. Always de-energize the circuit before working on any conductors or devices. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as safety glasses and gloves. Inspect all conductors and devices for damage before installing or connecting them. Make sure that all connections are tight and secure. When splicing conductors, use approved methods such as wire nuts or terminal blocks. Never use receptacles as splice points for the neutral conductor. If a receptacle needs to be replaced, disconnect the existing receptacle and connect the new receptacle to the existing conductors. Do not splice the neutral conductor at the receptacle. If the neutral conductor is too short to reach the new receptacle, use an approved splicing method to extend the conductor. When troubleshooting multi-wire branch circuits, start by checking the voltage at each receptacle or switch. If the voltage is incorrect, check the circuit breaker and the neutral connections. If the neutral conductor is broken, the voltage at the receptacles or switches will be unbalanced. One receptacle or switch may have a higher voltage than intended, and the other receptacle or switch may have a low voltage. If you suspect a broken neutral conductor, de-energize the circuit and inspect the neutral connections. Look for loose connections, damaged conductors, or improper splices. In addition to the specific requirements for multi-wire branch circuits, the National Electrical Code also contains general requirements for wiring and electrical safety. These requirements apply to all electrical installations, including multi-wire branch circuits. One of the most important general requirements is the proper grounding of electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The National Electrical Code requires that all electrical systems be grounded in accordance with Article 250. This article outlines the requirements for grounding electrodes, grounding conductors, and equipment grounding. Another important general requirement is the proper overcurrent protection of electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overheating due to excessive current flow. The National Electrical Code requires that all electrical circuits be protected by overcurrent devices that are rated or set at a value not exceeding the ampacity of the conductor they protect. The ampacity of a conductor is the maximum current that the conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on its size, insulation type, and insulation method. The National Electrical Code provides ampacity tables in Article 310. The proper selection and installation of wiring methods is also essential for electrical safety. The National Electrical Code provides detailed requirements for wiring methods in Chapter 3. This chapter covers a wide range of wiring methods, including rigid metal conduit, electrical metallic tubing, non-metallic conduit, flexible metal conduit, cable trays, and various types of cables. The selection of the appropriate wiring method depends on the application, the environment, and the applicable codes and standards. Electrical boxes and enclosures are used to protect electrical connections and devices. The National Electrical Code provides requirements for electrical boxes and enclosures in Article 314. This article covers the types of boxes and enclosures that are permitted, the requirements for box fill, and the requirements for supporting boxes and enclosures. All electrical work must be performed by qualified and licensed electricians. Electricians are trained to install and maintain electrical systems in accordance with the National Electrical Code and other applicable codes and standards. They have the knowledge and experience to ensure that electrical installations are safe and reliable. When hiring an electrician, it is important to check their qualifications and licenses. Make sure that they are licensed to work in the jurisdiction where the work is being performed. Ask for references and check their reputation. A qualified and licensed electrician will be able to provide you with a safe and reliable electrical installation. In summary, receptacles should not be used as splice points due to the risk of overheating, arcing, and reduced safety. Multi-wire branch circuits require careful attention to neutral integrity and proper splicing methods. Always adhere to the National Electrical Code and use approved methods for splicing wires. This ensures the safety and reliability of the electrical system. Remember to use junction boxes, wire nuts, terminal strips, or crimp connectors for safe and code-compliant splices. Always prioritize safety and consult with a qualified electrician for any electrical work.